And with that being said, I'd like to introduce the first speaker of the evening, Landon Viator, who is a software developer with Audiophile Engineering. And today he's going to be presenting prototyping distortion effects in MaxMSP for JUCE.
All right, cool. Thanks. Well, thanks for having me. This is exciting. It's a great opportunity. Okay, so I have a little slideshow put together. The whole idea of this presentation is prototyping in Max because it's a little easier to prototype in JUCE and you can get a lot done much faster. So what is MaxMSP? Well, it can be thought of as a DAW, not in the traditional sense, you know, like Logic and Pro Tools and Studio One are a kind of editor-based arranged view DAW that has like a linear view. And Max has this kind of view. It's just a canvas. But it is a digital audio workstation because you can do DSP in it, and it has a visual audio programming language associated with it. So it gives the user the ability to perform high and low level audio operations, where high level would be kind of abstracted away from the kind of nuts and bolts. So I have an example here with the JUCE decibels to gain function, where all you have to do is input the decibel value and it'll output the gain. And then low level would be doing the actual math. So I assume this is the same function that they're using. You're raising 10 to the drive divided by 20 or the input divided by 20. So that would be low level, kind of like the nuts and bolts code of it. So in the Max environment, you can patch together audio objects that are pre-made C++, DSP objects, GUI objects, non-audio objects, all kinds of objects that represent DSP methods in a format that kind of feels like analog mixing racks and module synthesizers where you can patch things together and create sounds. So there are other options for prototyping outside of JUCE with audio. So there's MATLAB, of course, and the free version of it, which is called Octave. And it's more of a programming language, like a regular programming language than MaxMSP is. So the thing that makes Max the kind of easier choice to me is that it's a visual patching. So it has like a real world analogy and it's intuitive even for people who have never used it before, because you're just kind of patching together audio objects, kind of like you would patch together synths. So it abstracts all of those complex audio operations into high level objects. And it also has low level objects too. There are code box objects, things that you can actually write code in, which is really helpful if you have that knowledge and you want to use it. It's super easy. It's plug and play. DAW users coming from Logic or Pro Tools will find some aspects of it similar to their software in a lot of ways. Some ways it's obviously going to be different. Like I said, this view obviously doesn't look like a regular DAW. It's kind of like a canvas. So, but once you start working with audio, it kind of makes sense. The documentation included is amazing for Max. It's actually built into the app, and you can actually access the documentation for each object by just clicking on it. And that documentation is also online at Cycling74's website, the owners of Max. As far as online tutorials, there are an endless amount of tutorials compared to JUCE. Okay, cool. So I'll take you through a little demo of how to use Max for the people who've never seen it before and never used it before. So making objects is pretty easy. At the top toolbar, there are some included objects. So like, for example, here's a toggle box. You can grab some of the Ableton Live objects right here that were made with this language. And then you can also type in and start typing the name of an object that you know exists. Like, so I'll take the sine wave oscillator, which is called cycle, and it'll autocomplete. Just hit enter and boom, you have a cycle object. So that's how easy it is to create objects. There are some at the top here that are kind of easy to grab. So you can grab a gain slider, a text box, that kind of stuff. And then there's a bunch of objects that aren't in this toolbox that you can just kind of type in if you know what they are. And then you can search online for what objects are in Max. So data signal flow. So to connect these objects to each other, you just go to the inputs and outputs of the object, which are called inlets and outlets, and you can hover over it and see a little tooltip and see what it does. So basically, most of the time, you can just take the outlet, click and drag, and boom, plug it into the inlet. And then I'm going to make a number box. It'll be easier to show you. I'm going to hit F for float, and it'll make a float box. And if I take this dial right here, boom, I connected it. I can lock the patcher and interact with it. And I've got the connection and it works. It's sending 0 to 127 to this number box, which is pretty handy. I can do the same thing with this toggle box, lock it. It's sending 0 and 1. So it's basically a bool, right? It's a toggle. So that's how simple it is to connect objects to each other. And then you'll see that if I grab out of the cycle object, this is an audio object, and you can see that the patch cable looks different. So that means that it's an audio signal coming through, whereas the regular gray cables are just sending values, you know, floats, integers, just control values like that. So for audio, you have to connect audio objects to other audio objects. So I can actually connect it to this gain, and that'll work. So unlocked and locked. So whenever you're unlocked, you can see the dots of the canvas and you can move objects around and you can grab patch cables. And when you lock it with Command E, you'll see that the dots disappear and you can actually interact with the objects the way they're supposed to be. You can click on them and stuff. So that's all unlocking and locking really does, is gives you the ability to actually kind of, it's almost kind of like pressing build, like you get to test it, you know? And then we talked about the types of objects. You basically have audio objects and non-audio objects. The audio objects have a tilde in front of the name, and they have a yellow and black patch cable by default. You can change these colors, but by default, that's what it'll be. And then the gray patch cables are the non-audio objects. Lastly, I'll show you how to see the documentation. I'm going to unlock it. If you hold down Option and you click on an object, it'll bring up a small max patch that actually serves as the documentation. You can see notes about adding arguments to the object. It'll usually have some kind of prototype that you can actually use. This is a good time to test. Can you hear the oscillator?
We can indeed.
Awesome. So you can see that the documentation actually gives you a test that's easy to understand and actually works. Whereas, you know, if you go to the JUCE documentation, sometimes you'll look at the explanation and it doesn't actually, you have to kind of have a lot of C++ knowledge already to get it to work. But the Max documentation is super easy to understand, and it's already set up and it already works for you. And there are actually usually some extra tabs for extra functionality of the objects. So that's how the documentation can be accessed, and it's very helpful. It's amazing. I love it. Okay, cool. So the whole idea of this presentation is, how do we make distortion? And I think the first thing we need to talk about is what really is distortion, because there's people describe distortion in all kinds of different ways. They'll say distortion, overdrive, clipping, saturation, you know, and they're really all kind of talking about a similar idea, which is just the deviation in the shape of the waveform from input to output. So if you have some kind of DSP process or transfer function, you're going to change the way the audio looks from the input to the output. And that's technically all distortion really is. And to prototype and make distortion, there's actually a bunch of different ways that we can accomplish this. So we could do this with trig functions such as, you know, tan, atan, even sine and cosine. You can use polynomials, which are in this kind of form, and I actually have a tab pulled up, polynomials. So basically you'll have like a number multiplied by x raised to some kind of exponent plus or minus another term. And that's basically all a polynomial is. It just means multiple terms. And what you would do, x would represent the signal. So you would just, if you were writing it out in C++ and you're writing the equation, you would just kind of input your signal as x. And I'll do that in Max. And then you can do direct wave shaping is what I call it. I don't know if there's a proper word for it, but it would be kind of like if you were in the process block of your JUCE project and you said, like, you know, if sample is greater than 0.25, do something, and you're changing the wave only at that top, like 75% of the positive form. That's what I don't know if there's a word for it, but that's what I call direct wave shaping, where you're just kind of doing math with conditionals or if statements or something to the waveform. And then something that's really helpful is adding a multiplier to your input, either before or after it goes into one of these functions. If you do it before, it'll give you more distortion and it'll give you basically a drive parameter. And that's kind of an analogy to how guitar amps work. I mean, you're sending your guitar into the amp and you'll have a certain amount of distortion by default. And if you increase the guitar's volume going into the amp, you'll get more drive and distortion. So yeah, let me just go over to Max and I'll start showing you a couple of things. So I'm going to get rid of all of this and I am going to make a output device. It's called the Easy DAC. That's what I use. I'm going to make a gain slider so that I don't blow your ears out. So here's a simple gain slider. I can connect it to the output in both channels. And you can see the gain slider is all the way down, so you shouldn't hear anything. And then I'm going to make a sine wave again. I'm going to do 220 hertz so it's not so annoying. And I just want to make sure you can actually hear this. If I turn audio on by clicking the button. Can you hear that?
Yes, it's a little bit low, but we can hear it.
Okay, yeah. So I'm gonna show you how to use the ATAN function, and then I'll do a polynomial just to kind of show you. One popular clipping algorithm that I got from Eric Tarr's book Hack Audio is the soft clipping algorithm, which this might be a little hard to see, but I'm gonna zoom in. It's just a little comment object. So the soft clipping algorithm is basically 2 divided by pi times the ATAN of your input or your signal multiplied by your drive. So that's that multiplier I was talking about. So it's very easy to build this in Max and very quick, and you'll see how much faster it is to do this in Max than it is in JUCE. Because imagine in JUCE, if you want to have some GUI objects to test with, and you're going to want to, make your audio processor state tree attachments and stuff, and it's going to take you a little while to set all that up, unless you have your own, little framework set up. But you can see how easy it is to just attach objects and create GUI objects in Max and connect them to stuff. I'm going to start top down, and I'm just going to kind of build this equation with Max. So we need 2 divided by pi. I'm going to make a signal, which is basically just a number at the audio rate. So I'm going to, since we're doing audio, everything's going to be audio. So I'm going to make a signal of 2. And I'm actually going to divide it. So like I said, everything with a tilde in front of it means audio. So divide it by, I'm not sure if there's actually a pi object, so I'm just going to do 3.14. So cool, we've got that. We've got 2 divided by pi, and then we're going to need to multiply that. So 2 divided by pi right here, and then multiplied by, we're going to say the ATAN. It's actually okay because I'm going to use a oscilloscope, and we can look at it that way. We don't even have to listen to it. So we've got 2 divided by pi, and then we're going to multiply it. And you can see that I'm thinking top down, and we're going to multiply it by ATAN right here. And then all we have to do is send our input multiplied by some kind of multiplier into the ATAN. So what I'm going to do is make a multiplication right here. Oh, wait, we're going to do this. And I'm just going to make an integer. Let's see. I'm going to make a scope object. And when you're on an object, if you want to access the attributes for it, you can hit Command I, and the right toolbar will pop up. And I'm going to move this out the way, and I'm going to select automatic mode for the scope object, which is really handy. That. And I should, there we go. So we've got our waveform for the cycle. Cool. And now our input times drive is right here. So if I start increasing this, we should see some distortion. or wave shaping. Oh yeah, look at that. It's squaring. Awesome. So what we're doing, if I go over to, I can show you what this equation is actually doing on a graph. If we go over to Desmos and I do 2 divided by 3.14, and I multiply it by the arctan of X, you can see the equation, or you can see the line that forms. And basically what we're doing is we're applying this line to the sine wave, and we're driving it harder with a multiplier. So if I just go in here and I just multiply it by 10, you can see now it's much more square, and it's kind of getting more constrained. And that's basically all we're doing to the waveform in Max. So it's really easy to test. You don't even have to have a known equation that works. You can just kind of start multiplying these objects by each other and see if it does anything cool to your waveform. So there's your drive function. And then we can do the same thing with a polynomial. And I'll just take the polynomial that was on that Wikipedia page, which is 3x squared. So squaring something in Max is pretty simple. You just multiply it by itself, and X is our signal, so we can multiply it by itself. And then I'll make another multiplication and multiply it by 3. And then what's next? Minus 5 times X, minus tilde right here. 5 times X, so I'm going to take this multiplication, change it to 5 times X. And then lastly, plus 4. I found that adding, if it's just a plus or minus of a whole number, it doesn't really do much for the waveform except, you know, shift it over, but we'll do it just for fun. Plus 4. And then we can see if it does anything interesting. Oh yeah, look at that. That looks like not a sine wave. That's pretty cool. But you can see the top range is at 12 and the bottom range is at 1.9. So you can add some multiplication and some addition to shift it over back to be around -1 to 1 if you wanted to. And then in the spirit of prototyping, since it's so easy in Max, I'm going to take a tan, and I'm just going to plop it in. Like I'm going to say the atan of this minus the atan of that. So let's see. I'll put it in here. Okay, we changed the shape again, which is awesome. Cool. Oh, wow, that's quite different. So you can see how fast and easy it is to prototype in Max, even if you're not really sure what you're going to be trying. And if you're doing this in a JUCE project, you know, you're probably going to be, you know, hitting build, trying a couple of things, opening it in your DAW, listening to it through an oscilloscope, checking it out, reopening the project, do it again. But this is much faster. And then I can do this. I can start adding my own multipliers instead of 3 and 5. I can just start doing my own. Yeah, look at that. We're getting something. And then since I know that that's driving it and making a weird shape, I can know that that can be my drive parameter. And in my JUCE project, I can send drive to these two terms right here. So instead of 3 and 5, I can make this drive. So it'd be like drive X squared minus drive X plus 4. And that's kind of the real spirit of prototyping, in my opinion. Like you can't really do anything wrong. Like, sure, you might do something that won't sound good, but you know, what does it matter? I mean, if you find something interesting, you'll know. And it's a lot more fun to do it this way. So yeah, that's kind of like a brief, very quick overview of prototyping in Max. So I'm going to take the SoftClipper and, oh, I forgot to open Producer, Distortion Meetup. I'm going to open that in Xcode. And of course, it's going to take forever.
As it always does. Thank you so much for this, Landon. This is really helpful for people that are just getting started.
Oh, I'm glad. I'm glad it's not just me rambling on. I'm glad other people find value in it. I'm going to delete the code because that's what we're going to do together. And I'm going to kind of show you what we're working with basically. So I'm going to do the SoftClipper. I'm going to build it in standalone just so that you can see what the GUI looks like, just so that we know what parameters we have. That first build when you open Xcode is always the longest, and then after that it's quick. And you'll notice that in my process block, oh, okay, finished building. Awesome. Here's my amazing GUI. We've got an input, a drive, a mix, and an output. And the input is going to be driving, or it's going to be adding a multiplier to the input. And the output is going to be adding a multiplier to the complete output so that it's a final kind of trim, changing the volume of everything. And then we have our drive and mix. So the mix is just going to be the difference between the dry and wet channel, or the dry and wet signal. So that's what we're working with for parameters. I already have all the listeners and attachments set up and stuff, so we don't have to worry about that. So my process block right here, I have it set up with the typical sample channel for loop, but I'm doing it based off of the audio block instead of the buffer. And that's just because I've been doing that recently, because whenever you abstract it out to a class, you'll probably have like a process. So it'll be called like softclip.cpp, you know, and then I'll have like a process block function where I pass it the audio block, just in case I'm doing, or I'm using other JUCE DSP objects that I'm using the audio block for. It just makes it consistent. You know, I don't know if it's like the best way to do it, but it makes it consistent so that my process block always has like, you know, filter.process, softclip.process, trim.process, whatever. And then I'm just passing it the audio block and it looks nice and clean. So yeah, that's how I'm doing the DSP in this example. I'm not abstracting it out to a class. I'm just going to do it directly right here. So the first thing I'm going to want is, even without having to look at Max, we need some kind of input variable. So I'm going to say const auto input is going to be equal to, I have data right there for the channel pointer. So I'm going to say data sample. And then I'm going to multiply it by the input variable, which I have already set up in the header. I've got an input DB that's connected to the dial already. So I'm actually going to multiply that, but it's in DB. So I'm going to call that nice JUCE decibels function. So I don't have to use PAL 10, blah, blah, blah. What is it? Decibels to gain. And then I'm going to pass it input DB, which is down here. So just with that, all I'm doing is being able to multiply the input and, you know, make the input louder, which will drive it harder. And then I'm going to say const, let's see, I'm going to call this SoftClip, I think, which is equal to 2 divided by pi. Now, I don't know if this is even really a thing anymore, but, you know, I've always heard that you're not supposed to do division in your code when you don't have to. And what I did was I went in the header and I just went ahead and defined what 2 divided by pi was with this math constant pi and 2 divided by it. And I just called it pi divisor. So that's just a quick and simple little way to do that in prototype with. So I'm going to say, oh, we have,
that needs to be const auto, by the way, SoftClip.
Oh, yes. Const auto SoftClip. If you remember, the SoftClip algorithm was that pi divisor that I made, and that was multiplied by the atan. So we call there's an atan. I'm going to do the atan F1 right here for the float. So this is going to be the input times your drive. So this is input. We already have that right here that we made above. And then drive is also in DB. So we're going to have to use the same conversion. Drive DB. Cool. So that's the atan. We've got 2 divided by pi, which is stuck in this variable, times the atan of input times drive. Yep, that looks right. And then we're going to blend it. And this is something I just picked up recently. A nice little blend algorithm. I think also from Eric Tarr's book, Hack Audio. So we want the mix. When the mix is 0, we want only the dry input. And when the mix is 100, we want only the like soft clip. So I'm gonna say, let's see, think input times, and then you could do this trick right here. 1 minus mix. My mix is the dial goes from 0 to 100, but I have it scaled right here. I have it scaled in the parameter change to divide by 100 so that it's between 0 and 1. Cool. So I think that's that plus SoftClip times mix. So let's take a look at this and make sure it's correct. So we're basically, we're adding the input and the SoftClip together, but then we're changing that with the mix. So when the mix is 0, that means that this equates to 1, and we're multiplying it by input. So input times 1. Yeah, that sounds right. And then we're adding SoftClip times 0 when it's at 0. So yeah, then we'll only have the input. And when mix is 1, 1 minus 1 is 0, multiplied by the input is 0, but then SoftClip times 1. Yeah, that's correct. That sounds correct. So that'll give you your mix between dry and wet. And then whenever these are at 0.5, so halfway, it'll be half of the input added with half of the SoftClip. So that'll blend it. Yep, that sounds right. And then we're going to add the output, right? So we're going to multiply that. Actually, I'm going to make it not constant. So we're going to say blend times equals the same conversion right here. And that's going to be, I forgot what I called it. Did I call it output? Yeah, output DB. And I think that's it. We just have to send it to the block, right? So we'll say data sample. We have to replace what's in there with what we want. And that's equal to blend. And I think that's it. Let's see, we've got our input. We've got our input, the actual input coming from the block multiplied by our input variable. We made a SoftClip algorithm times ATAN of input times drive. We're blending it with the mix. We are multiplying the entire mix by our output gain, and then we're sending that to the block. And I think that's it. Yep, that's it. That's about it. You can see I attached it to logic by going into product scheme, edit scheme. And I have the executable set to logic so that when you build it in debug, it actually opens in logic. And that way, whenever you hit an assert or something like that, it'll pause and show you where it is, which I didn't know existed for the longest time. And I think that's very helpful for people starting out. So now whenever I hit play, it'll open in logic. Okay, I'll open up my tester. It's a basic overdrive kind of soft clipping algorithm. You can basically do the same thing with the polynomial. And then you can just, let's see if I have it in max. Yeah. So I have, so 3x squared minus 5x. So it would be, x would be the input. So you would just basically write this out in your project in the process block, and then just replace x with input. And then you can replace 3 and 5 with your drive, and that would probably do the same thing, and you'll get a different shape. And then you can also, I'll show you this in Max real quick. If you filter after the distortion, you can change the shape a lot. So let me go back to doing the soft clip. I'm just gonna do this real quick, the ATAN. I'm gonna leave out the pi. Let's see, times tilde. that. Let me see. Make sure it's set to 20. Send it to the scope. We can see it's very square and very cool looking, but we can actually filter it. So I'm going to make a state variable filter in Max. I'm just going to do this arbitrarily. Like I'm just going to put a cutoff of like 1,000. And the cool thing about this object is you can send out the low pass output, the high pass, the band pass, and the notch. So you can try this very quickly, and you can already see that we have a really interesting shape right here that kind of looks more analog and realistic. And we can do the high pass, see what that looks like. Oh, I don't know about that. We got band pass. That's interesting. That's going to sound ridiculous. And then notch. Notch is usually the coolest one. This is very guitar amp distortion looking to me after taking some impulse responses of my amp and looking at them. This is very analog looking to me. So you can just use some filtering and change the shape of the distortion and make it way more pleasing and realistic. So you can figure out what filtering does the coolest thing to your audio, and then you can just remake that filter with like the included JUCE filters, and it'd be very simple. So yeah, use some filtering, pretty cool. And that's very quick, as you can see. And I think that's about it. That's kind of like my process of prototyping and then remaking it in JUCE. It's way faster than trying to code all of this and then see what it sounds like after building it, and then, you know, coming back, making a change, going back to Logic, building it. You know, it's much faster. And it's easier to get into than MATLAB because you can just patch things together, and it's more intuitive, especially for musicians.
Yeah, thanks, Landon, for this great overview. I think it's a really, really good thing to have in someone's toolbox, you know, when building and prototyping stuff like this.
Yeah, thanks.
So we do have a question on the chat from Yas, who's asking, Landon, do you use data buffer in Gen to make a LUT using peak and poke for your distortions? I have been doing it for a while, and process is way cheaper.
I have used Gen. I do use Gen a lot because you can use the code box. I haven't used the buffer object that they're talking about. I don't think I've ever used it. But what I typically do is, if you go into Max and I make a Gen object, so you can type Gen and you can get the one that has the tilde in front of it, and you can double click it, and you'll get another patcher. And this is the Gen environment. I can get rid of that. You'll have an input and an output that you can use. And what I typically do is I will make a code box, and I'll just say something like in1, which would be the inlet, is equal to an input variable. And then I'll send my audio into that inlet right here. And then I'll write whatever equation I want in here, and then just check out the output, which would be kind of closer to what you're doing in your JUCE project, but it's still way faster than, you know, having to press build, stuff like that. And so if you're already comfortable with coding, you can use the Gen patcher. And I think you can export the code from the Gen patcher, and it'll give it to you in some files. I've never utilized that, but I know you can do it, and I know people have done it, so that's an option.
All right, cool. So another thing which was mentioned, I think you mentioned it yourself during the talk, and then there was a comment on the chat about it as well. But you mentioned division. So somebody posted on the chat, the division is optimized the way if you divide by a constant and replace it by multiplication. It's not quite right, actually, because if you do floating point division and floating point multiplication by like the inverse, that's not exactly the same operation because of the way floating point works. Yeah. So the optimizer is not going to replace one by the other unless you specify F fast math, which is this option where basically you don't do precise floating point math anymore, but then you have other problems. So you probably don't want to do that. But if you don't do fast math, then the optimizer is not allowed to replace division by multiplication because it's not exactly the same operation, right? So then you would have to actually calculate the inverse yourself and then multiply by that. And if that's all, if you do all that like as compile time constants, then I guess that's the most efficient way to do this.
Yeah.
So yeah, you probably should avoid divisions if you can. That still applies as a general advice.
Yeah, cool.
You can check that on like Godbolt Compiler Explorer, like what the actual like, you know, output is, the instructions like for with fast math, without, and stuff like that.
Yeah, like you can go through the assembler instructions and see what's happening.
Yeah, exactly. And if you will see that by default, even if you do O3, like the division is still in there as an instruction, unless you do fast math. All right. I don't think we actually have any more questions on the chat.
I've got some questions.
Oh, cool.
Okay.
Josh, go ahead.
Yeah, so I know that a lot of other people who are just getting started must be wondering where you've learned about all this. And I was wondering if you could talk a little bit about the resources that you've used in the past to actually start learning how to do this. So you mentioned the great book Hack Audio by Eric Tarr, and what are some other resources that you use as well?
So another book that I use is Designing Sound by Andy Farnell, which is very similar to Hack Audio in that it takes you through a bunch of DSP processes, but it does it through the lens of Pure Data, which is a free version of Max. It's almost exactly the same. It looks a lot more low res, but the objects are almost exactly the same names. And that's what he does. And it's kind of more in the realm of designing sound. So I use that to, when I was working on a video game, to design like a fire crackle sound. So he basically in the book has a huge repository of different sound design patches in Pure Data, and he talks about the DSP behind it. Also, just going to Google Scholar and trying to search for, whatever DSP idea that you're working on or trying to work on, you might get lucky and find a paper that has the actual code version of the equations, because sometimes working through the math, especially if you're starting out, is very difficult if you're not already doing that. And I've learned a lot just in the Discord channel for the audio programmer in terms of distilling down math to whatever the code would be. So that's been a great help too. Everybody in the Discord seems to be very helpful and eager to help other people. So that's awesome. But those are the two books I use a lot. I've read through them multiple times.
Amazing. And what type of math would you recommend that people study? Like if they were going through university or they wanted to check out a course online that was focused around DSP, what would you recommend for math courses to get started?
I think I would say the course that I wish I would have taken, which is, some kind of pre-calculus or differential calculus. A lot of what you're doing is just linear algebra and kind of just getting yourself comfortable with writing equations, like, multiplying certain things to get certain effects. And, if I'm multiplying this and I subtract it by a certain amount, that'll even it out. Kind of like the blend algorithm was very, very simple algebra. And, most people are pretty good at algebra, but it kind of takes some practice to be able to kind of like conceptualize those things. And as far as other DSP processes, I would say that I wish I had more experience in differential calculus for like, time-based effects, because a lot of times you'll see either an oscillator or a time-based effect code that has like dt over dy, all that stuff that I wish I'd had more experience in. So that would be helpful.
Great. And you've created a couple plugins now, and I think if people wanted to get in touch with you or wanted to find out more about you, where would they be able to find out about you or get in touch with you?
So I have a website, landonviator.com. And I also have a Patreon, Viator DSP. So I have like 10 plugins on my Patreon that I routinely update the GUI and then update the DSP whenever I learn more things. So those are basically the two sources.
What an awesome resource. Thank you so much for your contribution and for giving this talk. I think it's been very informative for a lot of people.
Well, thanks. I appreciate the opportunity.